Well, hello guys. Happy New Year. Hi Natalie. Hi Ian. Okay, we have two today. Hi guys. Hi Natalie. Long time no see. How's your revision? Are you having trial by any chance, Natalie? You're revising lately, right? Right. Oh, you try and oh, okay. Oh, that means the next thing will be your SPM. Oh, okay. So wow. Okay, don't worry. We have time. Uh, I don't like saying that lah because usually it makes you relax. But don't worry lah, we still have a little bit of time to go through a lot of things, right? That would be in your SPM will start at 20th of February, so your sign should be around March, end of February or March, if I'm not mistaken lah. So you have around 2 months ish to go, which you should have plenty of time to prepare. Okay, so anyway, so what are we doing today? I'm sure you guys receive your January notes, right? Okay, your January notes, which I look a little bit different. The cover looks a little bit different, okay, because we changed the cover. Right, so inside that copy you have, oh, okay, nice, thank you. Finally, I look skinnier than who I am. You have your short notes, which is this one, okay, and you have the exercise one. So for these 4 weeks, right, we will revise Form 4 Chapter 12, and Form 5 Chapter 1, 2, 3. Should be quite long ago already lah, so most of you should have forgotten it already. So we will go through this. Right, so today, guys, it will be a very simple lesson because this Form 4 Chapter 12, it's quite simple. Okay, so I'll just cut straight to the point. Right, so this chapter is your nuclear energy. Natalie, were you here last year when I taught this? I couldn't remember. Were you here? Oh, you were. Okay, good. Right, so let's just jump straight to the benefit and the adverse effect. So this is the good point. This is the bad point. So what's good about nuclear? What's good about nuclear? This part, should you memorize this? I would say you can read lah, because this is more of a common sense thing, and it might come out in essay. Question 12 and 11 and 12. So there's a chance for you to get 8 marks here. Okay, so it's nothing difficult. Right, so what is the good point of nuclear? It is an alternative energy because it will replace, you can just say fossil fuel. Okay, so alternative energy, they can replace fossil fuel. That's why we use them. All right, because as we know, fossil fuel will run out one day. So this is an alternative energy, just like solar, just like hydro, just like wind. So another is nuclear. And of course, it has greater amount of energy. Okay, it has greater energy. So this is alternative, it's greater amount. 1 kg of uranium, just for comparison, 1 kg of uranium-235 equals to 2.7 million kg of coal. Can you see the difference? Again, 1 kg of uranium-235 is 2.7 million kg of coal. So why not use nuclear? You see, it is 2.7 million times better. That's why we use nuclear. Right? Anyway, so it will produce ionizing radiation. It will produce radiation. You might say, sir, isn't radiation a bad thing? It has some good points too. You can use them in medicine, you use them in agriculture, you use them in industry. The isotope we mentioned, remember? Cobalt-60 for cancer, iodine-131 for your thyroid, phosphorus, what's it again? 32, phosphorus 32 for plants, carbon-14 for plants. Okay, these are the good thing about radiation, and it releases very little greenhouse gas. Okay, very little greenhouse gas because nuclear doesn't produce carbon dioxide. You see, there's no carbon dioxide here, so it's better for the environment. Then what is the bad point? Okay, what is the bad thing? It can affect living things. Okay, as you know, it's radiation. Radiation is the main concern, and the mining is very high cost. I mean, you want to get this thing from the ground. It's usually very expensive. Okay, and of course, it can be used as a weapon, nuclear weapon, right? Funny, because when Western countries okay, like the Americans they want to build my nuclear power plants the people will make noise. Okay, but when the US government they use this to make nuclear bombs, they are quiet about that. So you see, this is a very hypocrite. This is a very double standard thing. Okay, and of course, it is a non-renewable energy source, just like your fossil fuel. Okay, just like fossil fuel. So these are good and bad points. Just really for fun, as I said, these are pretty common sense. Even if I cover all this, you should be able to answer. Right? Just think you will know. Okay, anyway, so jump to the main straight point. We have two types of nuclear reaction here. We have nuclear fission. Fission means breaking. We have nuclear fusion. Fusion means joining. Okay, fusion. Fuse. Okay, any of you watch Dragon Ball? Fusion. Dragon Ball is my era thing. Okay. Anyway, so fission is when you crack things into two. So we take a very heavy nucleus. In this case, we use uranium-235. Okay, we use uranium-235. Okay, can you see there are many balls here? Okay, there are many balls here, and they are very unstable. Okay, they are very unstable. So if I use a neutron, I use a neutron and I shoot it. It's like when you have a bunch of balls, you use a ball and shoot it, the balls will just brap. They will just, it's like a bowling. Okay, it's like bowling pins. So when this neutron comes and bombard this, okay, this thing will crack into two more stable nucleus, and this process will release a lot of energy, a lot compared to fossil fuel. Okay, this is a lot of energy. And what is the better thing about this? Also, the worst thing depends on how you use it. One neutron bombard this will create another 3 neutron. Okay, I guess you guys remember this. So 3 neutron will bombard another 3 uranium, and this process will produce another 9 neutron. And 9, you see, 1 becomes 3, 3 becomes 9, 9 becomes 27, 27 becomes 108. So can you see the reaction goes very quickly? So this whole thing is called a chain reaction. Okay, this whole thing is called chain reaction. It's like a butterfly effect. Okay, more and more and more and more and more and more and more. Before you know it, this is out of control. You have so much energy that it will produce very serious effect. So this energy, right? Okay, this energy, right? You can either use it for electricity. Okay, here's the thing about energy. You can use it to make good things. In this case, energy. Generate electricity. You can use this to do bad things. In this case, you use it for atom bombs. Right? So if you want to use, I don't care whether you want to make an atom bomb or you want to make a power station, a nuclear power station, you will use uranium-235. You use the same thing. Right? So there you go. So this is what we do with nuclear fission. Okay, and when this thing comes and shoot this thing, you have to use the word bombard. See, uranium-235 is bombarded by a slow neutron. So bombard means hit. This is like, okay, this is like snooker. You know snooker? You know pool? You use the cue ball and then you hit, all the balls will just spread everywhere. So the same thing. Right, so it will split into two stable nuclei and this release a lot of energy. And this is called a chain reaction. Okay, chain reaction. Okay, so this is nuclear fission. We crack things into two. Now let's talk about fusion. Fusion is when I join two things into one. So in this case, we use a very heavy one. We break it into two small ones. Now we use two small ones and we join it to become a bigger one. So it's the reverse. It's the reverse. Just now, heavy become light. Now light become heavy. Just now it's breaking. Now it's joining. So can you see the opposite? So this is fusion. So in this case, what is deuterium and what is tritium? This is basically hydrogen. Okay, hydrogen. Two hydrogen, they join together, they become a helium. And this thing also release a lot of energy. In fact, this energy is more than this. Okay, fusion has more energy, much more. This is already crazy. This is even crazier, much crazier, right? So you might say, okay, you might say, sir, then, okay, where does this happen, by the way? This only happens in one place. It happens in the sun. Okay, it happens in the sun. And many of you will say, sir, then why don't we use this? Right? We use this to make bomb. We use fission to make bomb. We use fission to generate electricity, right? Why don't we use fusion? Okay, the challenge, okay, why is it so hard to do fusion? Because this is, you need very high temperature. Okay, you need very high temperature. That's why the sun is very hot, right? I mean, can you, okay, can you use fusion to make a bomb? Yes, you can. It will be even more destructive. This is called a Tsar bomb. The Tsar bomba. Okay, this is even crazier. If you compare to Nagasaki and Hiroshima, this is a few hundred times stronger. This is a hydrogen bomb. This is a hydrogen bomb. Why is it called a hydrogen bomb? Because you use hydrogen, what? This is, or we call it a fusion bomb. This is even more deadly. Okay, but in history, we have never used this in a war before. Not yet anyway. Who knows, in the future, we will have World War III, and then we will start using fusion bombs everywhere. Then God bless us, we will all be extinct. Right? And you might say, then sir, why don't we use this to make electricity? Many scientists, they tried. Okay, this is called a fusion generator, fusion power. Now we use fission. All right. So why don't we use fusion? Because this is very expensive. Okay. Basically, think about this. This happens in the sun. You are basically creating a sun on Earth. You are creating a mini sun on the Earth's surface. Crazy. This is freaking a lot of power, and this is a lot of money. All right. Yes, the heat will be times two exactly. So, I mean, they successfully made this but it didn't function very long. They can only make the sun power for 30 seconds. That's all. 30 seconds, that's all. So who knows, maybe in the future we have this technology, but currently our technology is not advanced enough yet. Okay, advanced enough yet. Because sometimes you see, you want to do something, but you have to wait for technology to come. Okay, it's just like now, if you ask me, sir, why are we not driving Tesla now? Why are we not driving electric vehicles now? Because number one, they're very expensive, and number two, the battery is very unreliable. Okay, are you prepared to charge your car 4 hours, 2, 3 hours every day? No, you don't. All right, so the technology is not there yet, but it will be there someday. It will be there someday. See whether you can see this before you die, lor. Right? So in the future, okay, in the future, it's just like Avatar, okay, Avatar. You know Avatar? Okay, lately they came out with the second movie. The first one came out in 09. The first one came out in 09. This director, right? Okay, about this director, the director of Avatar is James Cameron. Okay, James Cameron, the same director who made Titanic. Right? I mean, Natalie, as a girl, you know what is Titanic, okay? It's the most annoying love movie ever. Okay, why? Because my mom watched it for 3 times in the cinema. Oh my god. I grew up in the 90s. They won't shut up about this movie. I was standard one. Everywhere you go, you hear Celine Dion. It's like, oh my god, shut up. Stop that stupid Titanic song. Okay, so after he made Titanic, right, he wanted to make Avatar. Okay, at around 99 or 2000. But they tell him the technology is not there yet because the whole Avatar is made from CGI. Okay, they use computer to generate the graphic, right? But unfortunately, that time, the technology is not there yet. I mean, he can make it lah, but it will look terrible. So he said, I wait. So he waited until 2009 when the technology is there, the CGI is already there, and he made, you know, the movie. Right? Okay, so you get what I mean lah. So okay, anyway, so this is fission and fusion. Fission is when you break things into two. This produces a lot of energy because of chain reaction. Fusion, they will produce even more energy. So this happens in the sun. Okay, so that's all. Pretty much that's all. Right, so let's talk a little bit about this electricity generator. This is your nuclear generator. Right, anyway, basically a generator is like a mini bomb. This basically is a mini atom bomb. It's a mini fission bomb. Because what's inside a fission bomb is the same as your generator. Okay, as this generator. Then you might say, sir, why won't this thing explode? Because in a bomb, okay, guys, give me a second. Okay, sorry about that. Right, anyway, so you might say then how is it different? Okay, let me put it here. If you're making a nuclear bomb, this is an uncontrolled chain reaction. It's an uncontrolled chain reaction. And if you're making a generator, if you're making a power station, a nuclear power station like this, you are doing a controlled one. You get what I mean? Okay, that means this is like a boom, this is like a fire. It burns steadily. So I mean, of course, we want uncontrolled in making bombs because when you're bombing someone, you don't say, I don't want to bomb so geng lah. I go light a bit so that not so much people die. No, you want full force power, right? You want to kill as many as possible. So this is uncontrolled, as much energy as possible. But generator is like we chill, we slowly release, and we slowly get the power. You get what I mean? This is like a sprint. This is like a marathon. The best way I can put it. All right. So how do we control this then? How do we control a fission reaction? How do we control this chain reaction? Okay. How do we control this? Basically, we use two things. Okay. Please highlight this. We use the boron control rod and we use the graphite moderator. These two, they will control the chain reaction. So as you can see here, what is the boron's function for? This is to control the rate of fission. See, control the reaction. Graphite is to slow down the neutron. So you see, both they control the reaction. There's a little bit difference. Like you see, boron, they control the rate, and graphite, they slow down the neutron. But if you say, sir, this one, many students will tell me, sir, these two, I'll get confused. Never mind. Then you just write control for both. Control the chain reaction. I will accept for both. Okay, I mean, better yet, you can just memorize the real function. So boron is to control, graphite is to slow down. Okay, so as you can see, okay, these two, they are very important. You get what I mean? If these two fails, your controlled reaction will turn into an uncontrolled reaction. Basically, you'll turn your generator into a bomb. Okay, so these two freaking important. So if these two fail, oh shit, you have a problem, right? Anyway, so let me explain how this thing works first. Okay, so first you have nuclear power here. This is nuclear energy, right? This is nuclear energy. So how do they? Okay, you might say, sir, nuclear is nuclear. Okay, chain reaction is chain reaction. How do we translate this into electric? Because we need electric, right? Okay, so very simple. You see, I use this to generate nuclear power, okay, nuclear energy, and this nuclear energy produces a lot of heat. So it turns into a heat energy, you see, it turns into steam. It turns water into steam. And this steam will spin this turbine. It will spin this turbine, and this turbine now is kinetic energy. right? Because moving what? Moving what? You know what's a turbine? You know what's a turbine? Have you cycled before? You know last time when they cycle, they have a mini generator attached to the wheel, and when you cycle, the headlight will go on. So that's a generator lah. So it's the same concept. It's just that the bicycle is smaller. This is much bigger. So you spin this turbine, and when you spin the turbine, you generate electricity. So it's a step-by-step thing. Okay, so very important. You start from okay, you can write this down. You start from nuclear energy because they will ask about the energy in the exam. You start from nuclear energy, you turn into heat energy, then you turn into kinetic energy, and then last you turn into electrical energy. So it's like a step-by-step conversion. Okay, so this is actually the same in fossil fuel. If you burn petrol, right? If you burn petrol and you burn coal, right? They do the same thing. You burn here, you create heat, you turn steam and turn this kinetic energy, and you turn into electrical. It's actually the same thing. All right, it's just that nuclear has much more energy, right? Much more. Okay, so a little bit about this uncontrolled reaction. Okay, remember just now I said if this boron failed and if this graphite they fail, if they fail, your generator will turn into a bomb, right? This was what happened in Chernobyl. Okay, the Chernobyl disaster. I think I told you guys this before many times. This happened in 1986. Okay, 1986. Okay, by the way, Chernobyl is in Ukraine. Okay, it's in Ukraine. And just in case, okay, a little bit of history. Before 1991, okay, before 1991, Ukraine is under the Soviet Union. You know who is the Soviet Union? Last time we don't call them Russia, we call them Soviet Union. And Soviet Union is a few countries, okay? It's Belarus, it's Lithuania, it's Estonia, Turkmenistan, Kazakhstan, Ukraine, and Russia. They are all under one country called Soviet Union, right? So that time, the Soviet Union, they built this thing in Chernobyl, not really for I mean, when we built generator, we want to provide energy for the people, right? They didn't do it for that. They do this to flex, right? They built this power station to flex to the US, like, you thought you guys can do it, only I can do it too. So they built this thing. And you know what's what's the disaster? They save money on the boron and graphite. They cut costs, right? They cut costs on these two, and these two, they fail. They didn't not to say they failed, they didn't function. The thing is already, when they build this thing is already not functional. So what happened? The thing turned into a bomb. So the whole thing exploded, and whole Chernobyl is contaminated with nuclear, with radiation. So it is empty since 1986. It's a dead city. It's a dead town. It's been empty for 30 something years. Yes, even now also. You can actually go inside for tourism though. It's really cool. Okay, but you must say then, sir, then the radiation, that's why you cannot go inside for long. I think you can go inside there for few hours, if I'm not mistaken. Just by inside for few hours, you already receive the radiation normal people get in 1 year. You get what I mean? Okay, I mean, for 1 whole year you get radiation, right? You go inside there for 4 hours, you already get that 1 year radiation. Cool what? You see, cool what? You see, next time you hear your friend, I holiday, I went for vacation. Where? You will hear boring places one. Taiwan lah, China lah, Bangkok lah. Where else? If a bit more can go to Europe lor, okay, or the US lor. You say you go to Chernobyl. See? You go to North Korea. Wow, you see, nobody went there one. Nobody goes there one. I mean, if you go, is it so cool? You bring a drone inside. Okay, if you bring a drone inside, you can view, you can take the photo of the whole city. Okay, you wait till I shit money first. I need to buy protective gear. Hey, even the air inside is radioactive. You know, the dust inside is radioactive. So when you inhale the dust, there will be radiation in your lungs. The more you know, okay? How is that cool? Cool, ma. Cool, ma. You don't get this like anywhere else. Right? Anyway, the same thing happens in Fukushima. La. Okay, the same thing happens in Fukushima. The Fukushima Daiichi disaster. So to say, this one, it's not because of safe cost. You see, nobody does things better than the Japanese, right? If the Japanese cannot do it, you most likely cannot do it one. So this Fukushima power plant was in Japan. So why did it fail? It's because of earthquake. This one you cannot say anything because this is disaster, natural disaster. And now the same thing. This Fukushima town is a ghost town. Okay, it's a ghost town because of this nuclear power plant disaster, right? So that's why you see this nuclear thing is a very big dilemma. Should you use it? Yes and no. All right. Some people say, it's good for the environment because I mean, let's face it, like you can't keep burning fossil fuel, right? And you know what's the worst thing? I think I told you guys this before. We are still 80% reliant on fossil fuel, right? That means even if you don't go out, right? If you don't go out, right, you say, oh, I'm a very environmental person. I don't drive out. Okay. I stay home every day. If you stay home, you still need to use electricity, right? Electricity still comes from fossil fuel. You are not running away. Right? So you see the problem? If you don't use fossil fuel, then what? Right? You might say, then sir, we use solar. Solar is only barely 5% of the world's energy. Okay, because to be fair, to be honest, solar they suck. Okay, solar power sucks big time because they're very inefficient and they are very expensive. Why not just use nuclear? Right? And then you have some people say, wow, but sir, nuclear very dangerous. You see Fukushima, you see Chernobyl, but those are old technology. So new technology, new fission power is actually safe. Okay, much safer than last time. All right, it's like this lah. When I was just saying about Tesla that day. Okay, I was just talking about Tesla. So a student told me, sir, Tesla safe to drive me because battery will explode one man. Right? So this student told me, sir, if I crash my Tesla, that means my Tesla will go on fire. Very dangerous leh. So I asked him back the same question. You crash your car, You know what's in your car? You know what is in your car? Petrol. Petrol can also catch fire, right? So what's the difference? Same thing also, ma. You haven't seen crash and then you see fire, man. Same thing one. So it's just okay. Here's the thing, sometimes when you read the news, I want you guys to use some of your own discretion because you see, news they like to write all these sensationalist headlines. You get what I mean? Your news will not sell if you say, oh, it's world peace today. Who wants to read that news? They want to read, wow, Middle East explode. Wow, Anwar said something stupid. Wow, they will sensationalize the topic. And then people say, wow, you see, wow, so bad. Then everyone will start watching the news. So news itself, it's full of emotions. It's full of negativity. That's why the more you read the news, the more you feel, wow, this world sucks, isn't it? This world is like so pessimistic. No, no, it's just headlines, clickbaits. Okay. Anyway. So about all these, you can read this yourself. This bottom part, right? This bottom part, please read for your own pleasure. They are not coming out for exam. Okay. Maybe here effect of radiation. Okay. Tiredness, nausea, cataract, blah blah blah. Genetic effect, deformities, mutation, cancer. Maybe this one. Okay. The rest a bit hard to memorize their function. You mean this one? You mean this one? You mean this one? Okay. I can use my way to help you memorize. Okay, let me think of Okay. The way I can see lah, because you see, I don't memorize things die one. I use memory technique to memorize. Okay. Whenever I see boron, I think of moron. Okay, I think of moron. So an idiot is responsible to control the rate of fission. Okay, or you can say graphite. You see graphite. Graphite. Do you know what's graphite? Graphite is a pencil lead. Graphite is a pencil lead. You use your pencil to slow down the neutron. Okay, imagine there's a pencil here. Okay, is it better? Is it better? I like to imagine stuff. I like to visualize my things. Okay. That's my way lah. Okay, if you want to use your own story, up to you. It's up to you. You always die memorize. You see, the thing about die memorize, right? You memorize it quickly, you also forget it quickly. That's why I always encourage you all to use memory techniques to memorize, because I don't want you all to study die one, because yeah, it works for now, but next time when you go to university, when information is overloading, you won't be able to do it. I mean, you can lah, but it's a very, very torturing process lah. Right? So I mean, this is my way of memorizing lah. So you can use your own. Anyway, let's go to the exercise, shall we? Okay, let's go to our page 2. Okay, so number 1, advantage of nuclear energy. So they do not emit, you can say, greenhouse gases that will pollute the environment. This one I just give you the answer straight lah. I don't want to waste time here, because SPM, they're not coming out with filling in the blanks. This is primary school. So number 2, do not produce a lot of particles. Okay, this one I'm not too sure. So such as dust, soot, and ashes. Okay, maybe because fossil fuel they will. Okay, they will produce this fuel. So only a small quantity is needed to generate large amount of electricity. Right? Reduce the use of fossil fuel. Right? You reduce fossil fuel. Okay, next. The cost of building a nuclear power station is high. Okay. And expose the worker to hazardous radioactive radiation. Okay, hey, something to ask you all. If working in a power station, if working in a nuclear power station, within safety limits, of course, but you still receive more radiation, but they give you 15,000 every month. Will you do it? Okay, 20,000. You go and work at a nuclear power plant. Still within safe limit. Will you do it? Don't want. Okay. Looks like someone don't need money. Okay. Anyway, so I mean, it's within safety limit lah. Oh, you know who else is exposed to more radiation than us? Pilots. Because pilots they are flying above the clouds. They are flying above the ozone layer, so they actually receive more UV ray though. It's an occupational hazard, but nobody cares lah. People just do it because pilot earns a lot, pilot pays a lot. Yeah, entire air crew, of course. The entire cabin crew, they will get more. It's a occupational hazard. Yeah. So in this case, being a pilot is more tight than being a cabin crew lah, because the pay is so big difference, but you get the same amount of radiation. I mean, that is if you are smart enough to be a pilot lah. So what maintenance? So you can say regular maintenance, I guess, is required to prevent accidents. You see, the high cost of nuclear it's not just building it or buying the uranium-235. You need to hire many good engineers, okay? Skillful engineers to operate your plant, because it's not that easy. Okay, anyway, so what of radioactive radiation may bring harmful effect to living organism? So the exposure, I think, may bring harmful effects to living organism and cause, you can say mutation, you can say cancer. I accept both because they're the same. Right? So again, guys, this might come out in essay. Might. So just, yeah, read it for fun. Okay, so next, let's go to number 4. So Natalie, you said your paper 2 very weak, right? You pray hard they come out with this law, because this is 3 marks. If this is, I don't know, is this easy for you? If it is, I mean, this is a very straightforward question. So if it comes out in exam, that means you have prayed enough. Your prayer has been answered. I don't know, but this chapter very seldomly come out because it's too easy. I don't know. Maybe you'll get lucky this time. So name the process. This is what we call your nuclear fission. Okay, nuclear fission. Walao. It's like that one ma. It's like that one ma. You see the Form 4 first 4 chapters, the temperature one, the CPR one. You think the one coming out, man? I mean, even if it comes out, don't you feel insulted? I don't know, leh. I always tell my students one. I mean, you can pray for easy exam papers lah, but number one, you will feel very insulted, and number two, everyone will be getting A's, and you'll be competing with more people for scholarship, for university and all. So, you still lose either way. Or because you didn't read, it's okay. I'll revise on that. Don't worry, because that one is very easy. Anyway, so this is nuclear fission. So what is X? X is your neutron. Yeah, the one blood pressure, yeah, exactly. Right. I bet you were not listening when you first got into Form 4. That's why you don't know how to do. Is it very normal one? Because most of my students, they don't care about those chapters one. They are what I call the rubbish chapters. Like, who cares? Like, if they ask you about BMI, you are like, "Ay, say lo, who cares? Who the hell remembers?" Because if you ask me, even I don't remember. Okay, see, what is the function of X in this process? This is to bombard the uranium-235 atom. I can just say bombard uranium-235. Right? So D, based on the diagram above, name the energy produced. Of course, this is your nuclear energy. Before they turn into heat energy, then kinetic, then electric. So nuclear. So one benefit, it's all here. It's all here. Yeah, so I'm gonna skip this. So what reaction is this? What type of reaction is this? Of course, this is a chain reaction. I don't know what the hell is this too. So it should be very simple. Wow, you see, if SPM looks like this, you untung lah. Anyway, so we look at one more. Okay, you might say, sir, what is krypton and barium? You don't need to care. These are just the smaller particles they become when they crack, become two. One becomes krypton, one becomes barium. So what is process X? Again, this is nuclear fission. Okay, answer this yourself. Name particle Q. Q is your neutron. The same question. So diagram below shows the flow of process of generating electricity from nuclear energy. So this is what we mentioned just now. So your reactor, they will heat water. Water will spin the turbine. Turbine will create electrical energy. So you see the energy flow. So what is the radioactive element used in reactor Y? That would be uranium-235. Malaysia doesn't have this. Okay, Malaysia doesn't have this. If we want to use nuclear power, we have to buy this thing From who leh? From China lor, from Russia, from the US. If you want, you can get it from North Korea. North Korea, they have this thing. That's why they very naughty one. Every time they test missiles by shooting their neighbors. Okay, you know, lately the fatty has been on it again. Our glorious leader Kim Jong-un is doing the exact bullshit again. He flew a missile to Japanese territory water. Okay, he flew a missile to their ocean. He always does this one. Yeah, no, to practice law. Okay, it's a military operation and you shoot it to Japan. What are you trying to do? Right? This fatty, he won't shut up one. Every few years, he'll do this kind of stupid drama, and then US will come out and scold them, and then they will chill again, and then they will do it again. No end one, right? It's like, I mean, the Japanese were very pissed lah. I mean, obviously, and then Kim Jong was like, I just doing military practice only ma. You so nervous for what? Why scared ah? 欠打 not right? It's like so this is equal to you. Okay, Chinese New Year coming right? You use your firecracker, you throw it to your neighbor's porch, and then you say, ma, got kena you man? You got injured or not? No ma. So serious for what? Practice only what? That is what you do every year. Very 无聊 one. Okay, so number 2, name the process which produce heat energy in reactor Y. So this is your process. Okay, this is your new. Why are they asking this so many times? Okay, nuclear fission. Okay, draw a flow map to show the energy change. Hiya, this one so easy lah. You have nuclear energy becoming heat energy. They already give you the hint here, ma. Is it heat? Then they say spin. Spin is what energy? Spin is moving, ma. So it's kinetic law. And then they even give you the final answer here. So that's electrical. Easy or not? Wow, 3 marks some more. Yeah, you slow it lah. Not gonna happen. So anyway, let's go to number 6. So this is the light one. Just now is the heavy one. So this is your nuclear fusion. Right, nuclear fusion. So what is the energy produced from the reaction? This is how many times do you want to ask this? This is nuclear energy. One condition required by the reaction to occur, you need high temperature. For your info, to make a sun, to create a sun, you need 15 million degrees Celsius. That's a lot of heat, freaking a lot of heat. The core of the sun is 15 million degrees Celsius. So, okay, unless you can reach this, you're not making the sun. So D, give one example of a place where this occurs naturally. So that would be your sun. So in a way, you can say the sun is a nuclear reactor. Our sun is a nuclear reactor. It's a big nuclear reactor. Because some people, they ask me, sir, since the space has no oxygen, right, how can the sun burn? The sun is not burning. You see, many people have this misconception, sun is a ball of fire. You can't have fire in space. There's no oxygen, right? So the sun is actually a nuclear reaction. It's a nuclear fusion generator. It's not a fireball. I mean, it looks like one, but it's not. So E, give 2 reasons why the reaction D occurs. Why D occurs? To produce heat, to produce light. This is a weird question. That means, why is there the sun? Okay, weird question. But anyway, anything goes. So number 7. So yeah, you see, you have your control rod. Sometimes they will even give you the name, you see. It's called control rod. And then the graphite moderator is to slow down. Remember, I use a pencil to slow down the neutron. This is to control the chain reaction. So what is the use of control rod? Okay, this is to control the nuclear fission, sorry, control nuclear fission, or you want to say control the chain reaction also can. So number 2, explain how the control rod performs its function as described. What they're asking this though, this is actually a physics question. How does it function? You can say it absorbs neutron. When you have less neutron, you have less chain reaction, isn't it? So this is how they function. But this is not important, okay? This is your physics question. So one element that can be used to make the control rod, that would be your boron. As I said, B is the same question, exactly same question. So you have your heat energy, and then you have your kinetic energy, okay, and so on. So C, water is commonly used as a cooling agent. Okay, by the way, what is a cooling agent? Right, since you see, there's so much heat here that is actually dangerous. So what do? They will make one more thing called a condenser, and they will cool off the extra heat here. Because it's too much heat, so they have something called the cooling tower. Now, whenever you see nuclear power plant, right? Okay, let me show you a nuclear power plant. When you see nuclear power plant, can you see the chimneys? Can you see the chimneys? These are not smoke. Smoke. You don't say, "You sir, this is bad. Is this smoke?" These are just steam. It's just water. It's harmless. So they look like this. It's just steam. Right? Anyway, why is the cooling system very important, and what happens if this system fails to function? Why is it very important? This is to remove excessive heat. Okay, to throw away extra heat. What happens if this system fails? Okay, the power plant might overheat and fail. They fail as in they explode lah. You have a nuclear disaster. All right, so anyway, let's do one more lah. Let's do one more, then maybe we can call it a day. As you can see, it's a very easy chapter. So name the method used in the power station to produce nuclear energy. Again, this is your fission, nuclear fission. X is involved in controlling the rate of nuclear reaction in the reactor. So what is your X? Controlling. So this is a boron control rod. You don't want to say boron control rod, then you say control rod lor. Control rod. Okay, so number 2, briefly explain how X carries out the mentioned function. So like I said, they will absorb a neutron so that it has less chain reaction. When you have less neutron, you have less bombarding of the uranium, so you have less chain reaction. So C, briefly explain how nuclear power plants generate electricity. You can say nuclear energy is used to heat water. So water turns into steam and spin the turbine. No way, 2 marks only. Why they never ask anything else? I don't know. I don't know. I mean, it's even a surprise itself lah. Even if they ask about the control rod, because usually they don't ask on. Because this is more of physics thing. It is more of physics thing. Oh yeah, by the way, before we is it done already? Okay, before we go, let me show you something. Let me show you something. You have not seen a power plant before, right? You've not seen a power plant before, right? So let me show you something. See if I still have it. Hang on, I need some time to find. Oh yeah, this. Okay, this. Hang on, let me share you this thing. Okay, this is a very interesting video of a nuclear power plant. You see, this is how they start up. Can you see the glowing thing? Can you see the glowing thing? The glowing thing is a uranium-235. The glowing thing is a uranium-235, and the water around is to cool the process down. And then the few sticks beside, if I'm not mistaken, they are the boron control rod. Whoa, so cool, isn't it? So cool, isn't it? I mean, you should feel scared lah when you are so near this. So yeah, it directly touches the water, yeah. And funny enough, even if it directly touches the water is not contaminated. Yeah. So I mean, you don't ask me the exact detail lah. I'm not a I'm not a nuclear scientist. If I'm one, then I wouldn't be here already. I'll be working in a power plant already. Okay, anyway, so you know what? I think there's nothing else for me to say. The rest of these are the control safety measure one. You can do it yourself, but I don't recommend it. You can just read the answer straight. I'll upload this answer to Google Classroom. Okay, you can just check it yourself. Hey, there's only 2 more questions left. Right, so I hope you learned something today. It's a very easy revision today. So next week and next few weeks also very easy one. We'll do chapter 1, 2, 3. And I think before we go for Chinese New Year, we have 2 more lessons. So we'll revise for chapter 1 and chapter 2. Okay, so Natalie, if you have anything, remember to WhatsApp me. Yuan, same goes to you. If you guys have anything to ask, feel free to WhatsApp me. So I'll just it's just revision. Okay, a lot of revision, and I will touch on the experiment paper. Section C, the one you asked me lah. Okay, so make sure you guys WhatsApp me. Do we do set papers? We will. Don't worry, we will. There will be the February last minute class, I think, and then there will be the seminar. So, right, the seminar you have to ask Auntie. You have to ask Auntie Teo. So, I'll see you next week lah. I'll see you next week, Natalie. Feel free to WhatsApp me if you have any questions. Right, so I will see you soon. Thanks. See you. Bye bye.